right, we're going to do page 2 as a screencast, mostly because in class we went over this experiment. So if you missed class, it may go a little bit fast, but you can pause it. All right, so page 2 of your worksheets. So we have an integer array called A, and it's set to 1, 2, and 3. So we've created that down in the box. Here's an A, and it's pointing here. All right, now when B is created, it is not given its own new space or new values. So when B is created, it just points right there. It is initialized to be literally the same as A. Okay. Now, C, well, so here, actually, if we change A at 2, 0, 1, 2, we know that this one means that the array that's printed out, B, if you print it out as a string, it will print 1, 2, 300, okay? Because A and B were initialized to be the same. Now you have to be able to make copies of arrays, that's just silly, right? So what if we made a brand new array? So int C is actually given a new space here, and it has the exact same length as array A, all right? So let's make this new array by copying it in. So a for loop would do that. For int I equals 0 to I is less than a dot length, C at position I is equal to A at position I. All right? So we're going to take everything that's in a box, so the element that's here, which is just an integer, gets copied into C's version of it, so that C gets every element of A. All right. Once that happens, if we run it, system.out.println array.toString print C, we should see that it's the exact same thing as A is now. And we'll just assume that it's still 1, 2, 300 like it was initially. All right. Then we change A at 1 to be 200. If we change A at 1 to be 200, so up here, this becomes 200. Now who changes, right? So we've still got A here. It's pointing to 1, 2, 300, and now this is 200. Okay? And we have B, and that's pointing up here. And we have, right? And we have C, and C is pointing to its own very own array where it got all of its values from A. So 1, 2, 300. When you change this one in A to be 200, nothing about C changes because C is completely separate. So C is still going to print out 1, 2, 300, where if we had printed out A again, A would have changed to 1, 2, 300. Okay? All right. Now, what is happening? Page 3, what on earth is happening? And you've heard a lot about this. So when you declare an array, like say that this is A, the computer sets aside a block of memory for it, and it stores the address of that block in this cute little box here. So it's some kind of complete garbage. I don't know. It looks like that maybe, right? And B will store, and then you put your values in. 1, 2, 3, 4. And right here, this is the block of memory A, C, 2, 3, B. I don't know, right? Now I'm saying this is storing it in hex, but I don't, when it prints something that's definitely not hex. All right. So and if you want to know what this looks like when you print it, just print A don't print arrays.toString of A. Don't send the array to a string. Just print the array itself, and it's going to print out the array's address. It's kind of a garbage version of it, but we did this in class. The fun part is that if you try to create B the same way by saying integer array B equals A, it's going to store the memory address 8C23B, whatever that is, right? Into this spot. And so both A and B are aimed at this place in memory, right? And if you print system.out.println A and you print system.out.println B, right? If you do the exact same thing for B, you're going to get the exact same garbage memory address, which is kind of cool. If you haven't tried it and you weren't in class, you should definitely try it. All right. So then if you did try to print C was over here someplace, I don't know, and C was storing a different address. So it wasn't storing that one. Maybe it was storing this block. I'm not sure, right? And so when you print out the value that's in C, it won't match these two. It's really weird, but cool. All right, so when you typed int C equals new a.length, it made a new block of memory at some other address. And then it copied all the values from A straight up into this one. All right, no big deal. But it's still a separate array, and it's not connected anymore at all. Okay, page 4. Last one. Can you now explain why you use dot equals to compare objects and not double equals? All right, so we have string 1 equals banana. String 2 equals string 1. True or false? So I'll give you a second. You need to pause the video, fill these in. True, false, true, false, true, false. What do you think they do? Okay, so that was me counting down. Why don't we look at the first one? So string 1 equals string 2. Yes, that is true. Let's look at the last one. Banana equals new string. Does that work? Nobody initializes things that way, but I believe it does work. Yes, true. Okay, and the second one. Banana equals banana. Those should be two separate bananas, but as it turns out, this is Java behaving very strangely, and this is a crazy thing. So if you want to understand why this is happening, I put a link in the Canvas posting. Okay? So this is a weird one. This is strings behaving strangely. Okie dokie. So if you put false for this one, then you're understanding things just fine. But it's not, it's true. Okay. On the bottom of that page, very, very last thing, we'll check with arrays. I'll give you a few seconds to do this. If you need more, just pause. All right. Let's see how that went. The first one is false. The second one, arrays.equals, array 1 and array 3. That is true. The next one is true. Okay. And the last one is, are array 2 and array 3 the same? Right here? Yep. They have the same address in memory. Dot equals is telling you, are the values the same? It compares values. And double equals values. Double equals is comparing memory addresses. All right? All right. I hope that this makes sense, and I will see you in class. Feel free to yell at me if it doesn't. Bye.